that, Maria. It's hard for me to see the questions because I don't have a second screen. So if you can kind of monitor them for them, and then if you see one you want to interrupt and let me know, that'll be fine.
I don't want to interrupt you. Let me know when you want to get questions, and I will help.
I'll do that. That'll work. All right.
Good luck.
Well, thank you, everyone, for attending. If for some reason my audio goes in and out, I'm across the ocean here. If my audio starts going out, just type it in the questions so that Maria will know, so she can stop me and we can figure it out. So, but hopefully everyone can hear you. So today I'm going to talk about R. R is a statistical programming language, and do kind of an introduction on it, and then go over a little few places where you can see R in the Microsoft tools. And so, so that's kind of the gist of today. So we'll get started here. So that's me. You're curious what I look like. I'm a data scientist for a global company in the Houston area. I've been working with data for almost 25 years, and a bunch of other stuff there. The only thing that's important on this slide is my blog, Stack Cowboy. I don't blog that much, but all the code demos I will show you, you can download them there. You can just go to my blog and look for, I forget the entry, I'll pull it up on the end. At the end to show you, but there's an entry there about code like a pirate. Just look for that, and you'll see the link to it's a link to OneDrive where you can download this PowerPoint, all the code I'll show you, and actually some extra code I won't show you, but that's there from other talks that I do. But you can just download that whole folder and get the code. So, and then if you want to reach out to me on LinkedIn, that's my there on LinkedIn, and then also on Twitter if you want to follow me, it's Stat Cowboy. So. And you can, after this talk, if you have questions, feel free to hit me up on Twitter or LinkedIn and ask me questions, and I'll answer them as soon as I can. So that's a little about me. We get started. So here's the agenda. The goal is by the end of this presentation, you'll have all the tools and information needed to begin your journey in R. And so what the title entails is an intro to R, talk a little bit why R. I'll talk about RStudio and the R tools for Visual Studio, so the IDEs and the actual R binaries to R. I'll go over some basics in R, go over the objects, different types of objects in R, go over packages, and then control flows, and then we'll end up with how Microsoft is incorporating R into their different products. And that says SQL Server 2016, but it's also in SQL Server 2017, of course. So then at the end, hopefully we'll have time to walk you through this regression demo, kind of showing you how we can use R to do statistics and different things like that. So, can you hear me okay, Maria?
Sometimes yes, sometimes not. Sometimes audio goes wobbly, but most of the time, yes.
Okay. So we'll keep going. So why R? R is free. That's a good reason you can use R. You have to pay for it. There's a lot of good graphics and data visualizations in R. Although for me personally, I'm a data scientist. I tend to use Power BI. I also use a tool called Spotfire, or another tool called SAS Jump, which is a GUI product from SAS Corporation to do statistics. But there are a lot of good graphics and visualizations in R as well. It's a very flexible statistical analysis toolkit. You have thousands of contributors contributing to R, which is that next line there. It's a very powerful open source community. And then also another good reason is that this is a Microsoft SQL Server group. Microsoft is invested heavily in R. They bought a company a few years ago called Revolution Analytics, which was the leader in kind of a commercial kind of variant performant version of R, and they Microsoft bought that, and they're using that leverage of that company, how they incorporate it in all their tools. So how do you get started? So the first thing you need to do is, if you can see my mouse pointer, is download R. So you need to download the R project for statistical computing from here. Just go there, pick your favorite Windows, I think Linux and Mac, whatever one you have, download it, install R, and just get the latest version. And then the next thing I want to do is put an IDE. The most popular one is RStudio. So you can click here, go to RStudio, download it. here's kind of a little what it kind of looks like on the right. I'll show you more about RStudio here in a little bit later. But RStudio is the most popular GUI and IDE for developing in R. If you're a Visual Studio person, you like to code in Visual Studio and you code all the time in Visual Studio, you can get the R tools for Visual Studio. So there's a link here, and that, allows you to run R inside of Visual Studio. Most people I know use RStudio. Even a lot of the Microsoft people I talk to still use RStudio. And it's a pretty good IDE, and it's free. You can pay for it and get support, but you can use it commercially for free, RStudio. And the last little note I have here is if you're working with Microsoft tools, if you start working with like the Microsoft Analytics Services in 2017 SQL Server, we'll talk about that a little later on, or it used to be called Microsoft R Services, but when 2017 came out, they renamed it to Microsoft Analytics Services, since they now supports Python and R inside of SQL Server. You can install this R client. And what this does is it installs a lot of tools and enhance R kind of packages from Microsoft that kind of came part of that Revolution Analytics purchase that allows you to do different things, including from your client connect to like the Analytics Services or Analytics Server to do different things. There's a link for that. And you don't have to have this Microsoft R client if you're just doing straight R, but if you're going to work with the Microsoft different tools and stuff out there, it's a good idea to install this Microsoft R client. So RStudio. So I'm going to talk about RStudio and use Demo in RStudio because that's what I use. It's the one I prefer. It's the one that 99.9% of the world uses to develop in R. And what I have here is just a little overview. So if we kind of start here on the bottom right, you kind of have 4 windows that you get in RStudio. The top left one will be your editor. This is where you can edit different files and write your R code. This bottom left is the console. So as you execute code in the editor, the output will come here in the console. You can also in the console type different commands just ad hoc if you want and run them. On the top right, you have the workspace. And what's in the workspace is all the different objects. As you're running code and creating objects, they will show up here in this workspace right here on the top right. And that's kind of what those are here. And then on the bottom right, I have I'll label plots, etc. You'll have, like, if you have projects, you'll have a tab here for files that are in the project, plots, so all the various plots that you might run inside your R code. Packages, so packages, we'll talk about them a little bit later, but packages allow you to add more functionality to R. And this packages tab right here, I know you can't see it, but I'll show you in a second where you can't see it, allows you to manage those packages. You can install them, you can update them all from this packages tab. There's one tab here called Help, so you can see Help, and then there's a Viewer tab it's for viewing different other types of objects. So that's kind of the overview of how RStudio looks. Some of the main options you'll use, shortcuts you'll use, Control Enter. So when you're in the editor and you want to run one line at a time, you can hit Control Enter on that line and it'll run it. If you want to run the entire file, Control Alt R will run that entire file that's in that editor. Some other cool things, built-in docs. So under Help, you have some built-in docs in the RStudio. Version control, so it actually supports version control. So like if you use Git, you can actually do version control inside of RStudio. You'll see a little Git tab show up over here. And then projects, so you can actually work and create projects and have multiple files in those projects and work with them. Just some little things I highlighted here. Here's the Help menu. You can see some options here, RStudio Docs. Another good one is this cheat sheets. So those are PDF files. A guy named Hadley Wickham creates most of them, if not all of them. And they have a lot of cheat sheets on like data wrangling, so manipulating data in R, doing graphics in R. They have shortcut cheat sheets for RStudio itself. So those are really good to look up. And then also here, different run options. So like the ones I use mostly are these Control Enter, Control Alt R, and the other one that I use a lot is Control Alt B and Control Alt E. So like if you're in the editor and your cursor is somewhere in the editor, if you hit Control-Alt-B, it'll start from the beginning of the file and run to where that cursor is. Or if you hit Control-Alt-E, as in Edward, it will run where your cursor is to the end. Those are the four I mainly use to run code. So debugging, we won't go into how to debug with RStudio. I wanted to put a slide out there for the people who develop a lot. RStudio does support debugging, and here's just a couple of the commands. But this is like an entirely other session that would take an hour to go through. But you can have breakpoints. There are functions like browse and debug once. And there's environment pane. You can do a trace back and a cross back. But not going to go much into debugging. Just wanted to let you know that it's there and give you a couple commands. And then in the console, you have some commands like if you want to step into a function, Shift F4, finish a function, Shift F6, continue running, Shift F5, and then stop debugging, Shift F8. But like I said, these slides about debugging are just more for informational purposes to let you explore about how to debug. But this is just the intro to R, so I want to kind of get more into the introduction stuff. So I'll stop for a second. If there are any questions?
No questions for now.
All right. So now we know like how to download R and how to you get the IDE and a little bit of basics about the IDE. So now I'm going to go into some basics about our actual language itself. So in R, a comment always starts with a pound. There's no multi-line commenting. It's all a single line comment. So if you want to comment multiple lines, you have to put a pound sign in front of each one of those lines. The good news is if you use a tool like RStudio, you can highlight multiple lines that you want to comment and hit Control-Shift-C, and that'll comment the line. And then if you want to uncomment those lines, you can highlight those same lines and hit Control-Shift-C again, and that will uncomment the line. And if you forget these shortcuts under the cheat sheets that I showed you earlier, that little help cheat sheets, there's an RStudio guide that has the shortcut commands in them. So variable creation. So everything in R is an object. So if I want to create an object called M and set it equal to 3 times 5, this is how I would do that. And so notice something kind of weird. In R, they didn't use the equal sign to set a variable equal to something. They use this less than minus sign. Now, all the latest flavors of R will actually support an equal. So you could say M equals 3 times 5. And sometimes when you download code, you'll see people use the equal sign. But typically what you're going to see in the code is this less than minus is how you set a variable or an object or a variable, same thing. Everything's an object equal to something. So in this case, I set an object called M to 3 times 5. And when I type M, it outputs 15. So help, if you want to get help in R, you can type help, and then, like in this case, I'm looking at a function called LM, it stands for linear modeling. And when you type that in the console in RStudio, it will show up in the little help window. So if I go back real quick, if I type help LM down here in the console, over here in this help tab, it will automatically go to this help tab and show you help for LM. Also, you can use the question mark. If I did question mark LM, it would do the same thing. Occasionally, you'll do help. It will do question mark in a function or a command, and it'll say, hey, I don't know. I can find help for it, and it'll tell you to do 2 question marks in the command, and then it'll kind of like search the web to find the answer for you. So that's how you get help. So that's the basics, comments, variables, help. We'll go into objects. So everything in objects are variables, values, command functions are all objects. Data in R is typically stored in 4 different objects. So I kind of put this in terms of all SQL Server people. So I kind of put these objects in terms of like how you think of database objects. So vectors are just one row of data with the same data type. It can be one. It can be. So if I go back here, this M right here, I set to a vector that had 1 element in the vector, and it was the number 15. So that's a vector, one row, same data type. You can have matrices. There are multiple rows and columns of the same data type. And then data frames, this is what you can think of like a table. So data frames in R are multiple rows with multiple data types. So you have rows and columns, and one column can be a string, one column a character, one column can be a numeric, one column can be a date. And so data frames are typically what you'll a lot of times spend your time working with data in R in data frames, because they are definitely as what a SQL Server person would think of as like a table. And so we'll talk a little bit more. We're going to go into detail on all of these. And then lists are just a collection of objects. So a list can have other lists. A list can be made up of vectors, matrices, data frames, or lists. And it doesn't have to be all the, like, a list doesn't have to contain just vectors or just matrices or just data frames or just lists. Lists can contain any combination. So you can have one vector, it can have two matrices, one data frame, and another list. They're just a way to collect objects up together. And I'll show demos of all of this going forward. But the point here are the four things: vectors, one row, same data type; matrices, multiple rows and columns, same data type; data frames, like a table, multiple rows and columns. They can be different. The columns can be different data types. And then lists are just a way to collect objects up. So vector, they're the building blocks for data objects in R. One little note here is very important. Most programming languages, indexing starts with 0. In R, it starts with 1. So that's a very important note to make notation of in R. Whereas most languages, when you create an element that has multiple items in it, the indexing starts at 0. In R, it starts at 1. So some vector commands to build vectors. C, which stands for combine. You can create a vector. So in this case, I'm going to create a vector called V with 5 numbers, and these are the numbers, right? Like by using that C. Sequence, it generates numeric sequences. So this is from 0 to 100 by 0.1. So I think that generates 1,001 objects, elements in that one vector. And I'll show you demos of all these in a second. The rep function will replicate values. So in this case, I'm going to replicate 1 and 4 4 times. And so we're going to put 1, 4, 1, 4, 1, 4, 1, 4. And I'll show you in a demo in a second. Colon. This will create a number sequence incremented by 1 or -1. So since I started with a lower number and then to a higher number, 1, 2, 3, 4, 5, 6, 7, 9, 10. If I reverse this and did 10:1, it'd be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Length. It's a function that will return the length of a vector. So this is important if you want to loop through a vector and do something with it. You kind of need to know the length of that vector. And so length will return the length of that vector. So real quick, I'll just go and show you vectors real quick. So can everybody see? Let me go in a second. I think I'm going to say it. Can everybody see that screen? If you
yes,
see
yes,
this font?
okay, it's fine. You can see it.
Perfect. Okay, so I'm just going to start off with showing you what I showed you so far in the demo. I think if I just keep killing you with PowerPoint, I'll get bored. So real quick, so this is RStudio. You can see here's the editor. I got a file called Intro to R. This is in a project called Intro to R project. One thing I will show you before I forget is on my OneDrive, when you go to my stat, I'll just do it there real quick. If you go to here, on my stat code right here, you can see this code like a pirate Intro to R. If you click that, you can see some information. The one thing is right here, download from OneDrive. And so when you click that, that's going to go to my OneDrive and you'll see all these files. And so what they are is, this is the PowerPoint that I'm presenting right here. 2 in there. Oh, I see. This is the one from Summit. This is one from SQL Saturday. This one I just stripped out a lot of the stuff that was in Summit. but also have all the sample stuff up there. So right now, this intro to R project, this is what I'm showing you now, which has the basic demos. Later on, I'll show you the linear regression one, and here's that project. So you can go to my OneDrive and download all of this. Some code about how to install packages into your SQL Server, SQL code to show you how to run R inside of SQL Server. Another thing about how to use R to do sentiment analysis. So we won't go on the sentiment analysis one or the advanced services one, but because those are for different talks, but I left that up there for you. And also there's a PBIX for Power BI. So to show you, I have an example I'll show you in a second at the end, how you can do R in Power BI, but here's that sample I'll show you there. So this is kind of all the stuff that's there. So you have a lot of, everything I will show you now. Just want you to let you know, you can go to my blog, click that OneDrive link, and download all that. So, having said that, this is what's in that intro to R project. First thing to do is use this command called RM and get rid of any objects in my workspace. And then for just so that I don't get a bunch of warning messages, I'll turn those off. I don't recommend you turning off warnings in your code. When you're coding, you want to see them. I just turn them off for demo purposes because it scares people when they see warning messages. So here's the basics. I kind of showed you this. So if I said M, I run it, you can see where M outputs 15 here. And if you notice in the global environments, I'll have an object called M, and it tells me the value. This is very helpful, this little thing right here. I want to create a vector called V, and now you can see the vector called V, and you can see the indexing here of 1 through 5, and there's the values. Same thing with sequences, so 1 through 1001, and you can see how it works. R repeat, so there's that function repeat 1414 1414. Colon. And as you see, I create. So if I say length of colon, you can see that it's 10. Right? You can do things like, sorry, hit a wrong button there for a second. You can sort vectors. So if I create a vector called S, you can see now there's S down here, 2, 3, 4, 5. If I want to sort it, I can call the sort function, and now it's sorted. All right? So that's vectors. So we'll go back to the PowerPoint and talk about matrices. So a matrix, like I said, can be multiple columns in a row of the same data type. There's a matrix function used to build matrices. There's also this rbind and cbind function. You think of rbind like in SQL as union, and then you think of cbind as like a join, so to speak. And so rbind does is take two matrices and combine them together to form one matrices, and what cbind does can take two matrices and join them together, but at the column level instead of the row level. And I'll show you a demo. And those of you who are interested in matrix algebra in R, I put a link right here for you. And I'll show you some demos of matrices in a second. We'll go through data frames list first, and then show you some demos, and then I'll stop for a few questions. Okay? So data frame, it's like the table. Some important functionality in data frames to know functions, row names, and extract row labels. So in R, R has a way to actually label each row. And you'll see some data sets that you might use as demo data sets that you get from R or on the internet where they have row labels. Most of the time, people nowadays I don't see use the row labels that often. They'll just create a data frame from like a CSV file or from the database using RODBC and read the data in. And the row labels will exist, they'll just be like 1 through the number of rows. But they do have this concept of row labels. I'll show you that in a demo. And then column names, so if you want to extract the column names or the column labels, you can use this function called column names. And then names is used to set the name. So if you write a data set in and it had headers in it, and you didn't like the names of the columns that were in the header row, you can use this names function to change it. Just a little list of a few different options out there to create data frames. Read table, I'll show you a demo. This allows you to create a data frame from scratch, and you type out the headers, you type out the values. Read CSV is exactly what it sounds like. So read a CSV file. Read Excel, what you would think it is, you can read an Excel file. And then RODBC, it's package that allow you to use ODBC to read in data using ODBC. List, they combine multiple object types in one object. And they can be any one of these vectors, matrices, data frames, list functions. They can all be put into a list. And they're great. One of the things cool about lists is sometimes I can create a list of a data frame and split that list up, put that data frame up and list to have multiple data frames inside of the list and use it to produce looping. This looping in R is slow, but I'll have a demo of this later. So stop on that, show you a demo on matrices and data frames and lists, and then I'll pause for questions, which I don't have any. So real quick, I created a matrix called M1, and basically what I just did was I'll create another one called M2. If I print them out, you can see what they look like. So I created this M1 that has 4 rows. That's what NR stands for. NC stands for 4 columns, 4, and all of the values are 1. And I did the same thing again, same number of rows and columns with values of 2. And I did it purposely in 4 and 4 so I can show you these R bind and C bind. This is important if you do R bind. Make sure you have the same number of columns, right? So if I do the R bind, you can see now where I have this one matrix that comes out that has that first matrix and that second one. I do C bind. You can see now where I combine it this way, right? So C bind, you have to have the same number of rows. And for those of you who do matrix algebra and things like that, do product of 2 matrices, you can R bind them and do product C bind. We're just playing, having fun there, but that's just for math geeks. So one of the things you might ask yourself is, where we use matrices in R, and so like say Python, for example, they're called NumPy arrays. We use a lot in deep learning. So if you think of like an image, it's made up of pixels, and those pixels have numeric values, right? If it's a RGB 24-bit image, you have one layer of X and Y's that have values for red, another layer of X and Y's that have values for green, another layer that has X and Y's with values for blue. And so it's often we'll create a matrix of those values and then use them to build the neural nets and stuff to do like image detection and things like that. So that's one of the ways we use matrices. So data frames. So these are like the tables. In fact, it even says read table. So in this case, I'm going to create a data frame called df using the function read table. I'd say it has header equal true. So there's my header rows, ID, name, Sal. Strings is factor. This is an important thing to note in R. What this says by setting this to false is it says take these names and by setting strings as factors as false, don't create them as factors. And what a factor is in R, it's a oh shoot, my brain just went blank. Sorry. It's like a representing, like, so if you had male, female, that could be a factor. Either you're a male or a female. Or if you had places like first, second, third, that can be a factor. So it's categorical. That's the C word. My brain went blank. So like categorical variables. Well, name is not a categorical variable, right? But if I had sex here, I might want to treat that as a factor. But typically, I'll read my data in with strings as factors equal to false. And then after the fact, I can use a function called as.factor to convert a column to factors. But for now, just know that typically when you're reading the data in or creating data frames, you'll probably use strings as factors equal false. And so what happens is here is, and then text equals. So this is then the text where I'm creating my data right here, right? And so when I create this, so I'm just hitting control here. Notice how smart it is. RStudio knows that that's all one statement. And so now it's created a data frame called df. Notice over here in the environment variables right here. It created a data frame, but notice there's this little blue thing. If I click that down, you can see where it created ID, name, Sal. And then these are integers. Recognize those are integers. Recognize those are integers. And then recognize these are characters. So just to show you what factors look like, I'll just set this to true. Rerun that. And notice now how it changed it. Now it says name as a factor with 10 levels. Because it had 10 distinct values. but I'm going to set that back, which doesn't make sense for name. So now it's back to being characters. One of the cool things you can do, if you look right here, see this little grid here next to it. If I click this grid, it'll open up my data frame in the window so I can see it. It's read only, you can't edit that, but you can read the data frame. If I do a class, you can see this is data.frame. And then if you do view, it does the same thing as if I click this little button there. It opens my data frame up where I can view it and look at its contents. So moving on, call names. So you see right here, I get my call names, row names. So my row names, like I said, because I didn't actually specify labels here, I didn't create labels. I just set my labels as 1, 2, 3, 4 to 11 because I have 11 values. When I get the number of rows in a data frame, use nrow. When I get the number of columns, then call. If you want to reference a column in a data frame by name, you can do that. So if I just say data frame and then I use these brackets, name of the column, I get back a vector of those names. Actually, I get a data frame with just one column. You can manipulate. So I can take data frame $, a column, and I can set that to new values. So if I give everybody a 5% raise, I just do like that. View it again, and now you can see everybody has a 5% raise. Make sense? So accessing by row or column numbers, or access by row, you use this bracket, rows, the first part. So I haven't specified anything for the column, so I get the whole row back. I just want to get one cell. So row 1, column 3, so that's the salary for this me, row 5. I just want to get a column. I can do that. So it's the same thing as here. So this is the same thing. These are doing the same thing. Since column 2 is name, we're doing the exact same thing. Okay, good. No questions? So list, you want to create a list?
Yeah.
Yes.
No, we don't have any.
Yeah. So list, so if you notice I created 2 matrices earlier, matrix 1 and matrix 2. And then I created a vector called colon, that's this data frame I just created. I'm going to put that as a list. I can just use this list from came in, put all the objects I want in that list. And if I click that list, you can see there's all the objects in that list. If I want to reference the second object in that list, I just do 2 brackets. The object number I want, reference it. If I want to reference the 4th object in that list, and then since I know that 4th object is a data frame, I can then get the first row. So that'll be what you just saw earlier, right? Since that's this right there. So that's that. Just to give you kind of idea about list, one of the things, a lot of the objects, like when you run different things in R, in this case, it's run a linear model. A lot of the output is really in the class object. It's technically a list. So don't worry really what I'm doing as far as this part here. I'm just running a linear model, fitting it, and then if I do this type of amount, you can see that this is a list. So that's how R uses a list a lot. But then if I do the class of that object, it's actually a class of LM. So that is list in data frames. So those are kind of all the basic object types you know for R. So missing data, NA is used to represent missing data. So I know there's an is NA and which function we use to manage that. Let me make this bigger again. So if I set a vector called X and I put this NA here, I print it, you can see there's NA here. And if I use this which function, I can use is NA and which to return the location of the values, not the actual values themselves, that are NA. So if I do this M, which is NA and X right here, I can see location 4. That's 1, 2, 3, 4 is NA. And then if I do which and then this is negating it, is not NA, I get 1, 2, 3. You can also get, in this case, what I'm doing right here is setting a value called Y from this vector X, and I'm saying give me all the values that are not NA and X. And by doing this, this is setting, it's like taking X, bracket, extracting all the rows that don't have NA, or all the values, the elements in that vector that don't have NA. And so then when you look at Y, you get these first 3 values, which is these 3 here. This is the missing data. Going to packages. So packages and add-ons for R. The library will list all the packages you already have installed in your R environment. So when you install R and you start installing packages, the library will list all the packages already installed. If you use RStudio, you'll never type this library command. You'll probably never type install.package command because we can do all that in RStudio, which I'll show you in a second. But I mean, occasionally you'll actually run the command line install. And you can list multiple packages separated by comma. Library. So this is, once you install a package in R, you can load that package to be used in your code with the library command. So, let me demo those two, the NA and the packages real quick, and then move on. So, missing values, there's X, I set it, I print it, you can see there's the NA. So if I do N, get all the values that have NA, I do V, get all the values that don't have NA. I print, you can see location 4 is the NA, which is right there. If I put V, locations 1, 2, and 3. And then if I just want to create a vector that has all the values that are not missing, I can say Y. So this is X, and I'm going to bracket this function here. If you look right here, this will just return the ones that I say, which is 1, 2, 3. And so I get all those rows, those elements, excuse me, and you see right there, right? There's kind of different things. So in statistics, a lot of times when we're dealing with data, we have to look at missing values and do something with them. So a lot of times we'll impute that missing value to, like, say, the mean. So in this case, if I print X again, you can see I have this NA here. Well, if I want to set any NA value equal to the mean of all the records in here, I can do something like this. I can say X, which is NA, so go find all the ones that X that are equal to NA, and set it to the mean of X where they're not NA. And so now if I put X, I now set that missing value equal to the average of these 3. So this is the library function. You can see now, here's all the libraries I have, packages I have installed in the environment. But what I do is I come over here, click packages, and leave it all there. And you can even click on them, type links, they give you help. You can install packages, so if I just click install right here, I can say, let's type like dplyr, click right there, hit install. I'm not going to click install because it's installed. It'll install it. And usually leave this checkbox. I always leave it checked because if there's any dependencies for this package, it'll automatically detect the dependencies and install them as well. And you can do multiple, either by comma or by space, install multiple packages. The other thing you can do is you can click update here, and it's going to go and look and say, hey, I've got lots of packages I need updating. I'll do this later, but then I can say select all, hit install updates, and it would go install the updates. This is a good way to manage packages. Okay, so here's the command line. I found it out because I'm accidentally running the demo, but this is how you install packages. Excuse me, button. But once the package is loaded, in this case, for this case, I've installed this package ggplot2 right there. If I want to use that ggplot2, I have to use this library command to load it. So now that it's loaded, I can call this qplot, which stands for quick plot, and plot a nice box plot using the ggplot2 package. And with this pretty graphics. So if you're doing any kind of graphics in R, learn ggplot2. A good way to learn that is go to cheat sheets and say data visualizations with ggplot2. Because they're very good. So that's packages, that's That's packages, and that is how to deal with missing values. So now we'll go into like conditional operators and control flows and logic. So comparisons in R return a logical vector. So remember everything, the building elements of R are vectors, right? So if you look at a vector as one row of the same data type, you look at a matrices, you have multiple rows of the same data type, right? So they're built up as matrices. You look at a data frame, each column can be thought of as a vector, right? And so when we do comparisons, we return this logical vector. So in this case, I set x equals to 2, and I say x is greater than 1, it'll return true. But then again, I can use, if you know this colon function I did, I can create a vector of 1 through 10, and I can say where it's 1 through 10 vector, the one that's equal to 2. Well, remember, it's 1, that's 2, so 2 is equal to 2, and then all the rest of them are false. So I get this vector of logical comparison. If I get the one that are not equal to, that's every one but 2. And then just going down the list, I won't walk through all these, but greater than equal, less than equal. So just some different things. So x is equal to a vector 1 through 4. So then I can use this the or, so say do or. So x greater than 2 or x is less than equal to 3. We're all that way, right? So this is one, or this is how you do or. So one of these conditions has to be true. This is and. So both conditions have to be true. So these have to be greater than 2 or it has to be less than equal to 3. That's only 3. Right? And so here's x, 1, 2, 3, 4. So only 3 is greater than 2 and less than equal to 3. Then it also has exclusive or. So exclusive or means only one of these can be true, but not both be true. And so in this case, x is either going to be greater than 2 or it has to be less than 4, but it can't be both. So 3 is greater than 2, but it's also less than 4. So that's why it's false. Only 1 and 2, which are less than 4, but they're also greater than 2, are true. And only 4, which is greater than 2, but 4 is less than 4. So that's exclusive or. And then there's a really cool function in R, you'll use this a lot, called n. So remember x is 1, 2, 3, 4. So I'm going to create another vector here called 0 through 5. So I have a vector with 6 elements, 0 through 5. So that's 0. And I can say 0 through 5, %n, %x. Remember, x is 1, 2, 3, 4. So there's 1, 2, 3, 4 are inside of 0 through 5, but 0 and 5 are not, so they get false. So I'll go back and show you some demos. If then else control flows, so it'll call x equals 4. If x is less than 3, print true, else print false. This is backwards. It should say if x is greater than 3. I'll fix this in the demo. I'll fix it in the slides too. If x is greater than 3, print true, else print false. Another way to do it is you can use this if else. And so this is the same thing as this, but you're just using commas to separate this. So this is saying if this is true, do this. If it's false, do that. Different for loops. So I can say for I in 1 through 10, print I 1, colon. I'll demo these to make more sense. For I in 1 through the number of rows in that data frame I created earlier, loop through that data frame and print each row. That's what that's doing. Then one thing about control, you break, connect, continue, like you do in any programming language. So you can break out for loops, you can continue, and you can do next. So while loops, so instead of variable, go I, while I is less than equal to 10, print I, and increment I by 1. So there's your while loop. So let me demo that, and we'll go back to our tools in RStudio. Here's the comparison operator. I'm just going to run through these real quick. So you can see, right, 1, so if I create this vector 1 through 10, so if I just run this, so if I like this, excuse me. So you can see what I'm doing here in the vector, right, 1 through 10. I'm saying the one that's less than equal to 2. So if I that, only 1 and 2 are less than equal to 2. You see how you get that logical vector? So x is 2, is x greater than 1? True. So logical operators, just to show you that those demos all work. So control flows, if x is 4, you can see where I fixed the code in my demo. If x is greater than 3, which it is, 4 is greater than 3, put true. This does the same thing. And then just to show you a more complex if, like, so this is like if, else, else, so the same thing. I'm going to do that, just have that. So that's in the demo. It's on the slide with the demo. And then nested, so for loops, just simple for loops. So for I, 1 through 10, right? So you can see what I'm doing here is I'm printing a vector 1 through each one. So 1 through 1, 1 through 2, and so you see, this is just for demo purposes. So if I move my data frame right here, so I come up here, I come in data frame, you can see my data frame has 11 rows. So if I want to move through that data frame, I can say for I in 1 through the number of rows of the data frame print, and then it prints out each one of those rows. While loops, so they're equal to I equal to 1, and then loop through it, just bring an I. So. So then what's not in the slides, like functions. So R is a functional programming language. So if I want to create a function called bonus, and it's similar to what I did earlier, but in this case I'll use a function to do it. So create a function called bonus. And what that does is it inputs sal and says, okay, take sal, multiply it by 1.05, and create this bonus and then return bonus. So now I have this bonus function. You know, if I view my data frame, which I just did earlier, excuse me. There you go, you can see 105 on that. So similar to what I did before, except they're sort of just doing math and they use this bonus function. So if you have like a really complex way you calculated bonuses, for example, you can make that function as complex as you need it. Then you can say, okay, excuse me, I skipped over something. I just created a copy of my data frame called bonus, just to show. And so now I'm going to say, take the sal column and use my bonus function now to hide the bonus. And view that right there, and now you can see all the bonuses that. So we can do different things. So you can take this function and do all kinds of things. And functions can take in multiple items. So I can take in the ID or the name as well. I can do that. And then you can do things like if name is equal to Jamey, and bonus is this, else is that. So I get rid of that before I save it and make my demo. But that's just kind of to give you an idea. You can have multiple inputs into your functions. Try and catch. Here's a little note on exception debugging from Hadley Wickham's site. So set the options to show error messages equal true. I'm going to say results A plus B. Well, these are characters, so I can't add them. So I do that. It throws an error, right? If I set the options to show error messages equal to false, now I run this with try, it caught that. So my code will continue to run. And then now I can just say print results, and now I print results. I see that I have this error. This is some other stuff I'll go over just to show you that's in the demo. You can play with them. Some things called dynamic graphs. They're kind of cool. Hopefully I have all these packages loaded. I'm not sure why that didn't work. You can play with that. I'll have to play with that. This should work for your code. Something's not working on my laptop. We should get a cool little graph that has a slider that lets us slide the time range on this time vector. So for example, if you want to write a CSV file, so I'm going to view this data set called empty cars. And then I set those row labels. In this particular data set, empty cars is just a sample data set that comes for free with R. You can see this has row labels. Instead of there being 1, 2, 3, 4, it's the name of the car. So if I want to write out a CSV file, you just run write CSV file, what the data frame is I want to write out, what the file name is. We don't specify a path. It'll write it out in the default environment. So you want to make sure you set a path. append equals false. So if the file exists, it'll overwrite the file separated by commas, and call names equals true. So I get the headers in that CSV file. So then some other stuff to play with. I won't go through this because of time, but just more fun with lists and different things. So basically what I did is I created a thing called class grades using the read table. And what I'm going to do is calculate what your final grade is. And what I've done is I've using a couple of packages called dplyr and tidyr and different things. I have like 10 different ways to calculate your final grade. This first one is really simple, using spread and apply from tidyr. Pivots the data and then does this apply to get the mean and then gives you your final grade. So if I show you this, let me build my data set. So we get the mean of all our grades. So now if I want to say let's get the final grade, I just create a frame called final grade. And so if I look right here, you can see how final grades now been split this way, whereas before it was like this, right? So this is using spread. I've pivoted my data, and then if I then go and use this apply function, I can apply over the columns 2 through 4 and get the mean. And if I do this, now you see I have a new column called final grade, which is what I set right here. That's my final grade. And then just for giggles, that's the way I would do that. But you want to see all kinds of different ways how I could do that, using for loops, which are really slow and bad, using the split. So when I talk about lists, a lot of times we split the list up using the split command, calculate it, and then we can combine the list back together. That's the add rows, dplyr, using add rows, SQL df. So SQL df allows you to use SQL statements. So I can actually say SQL df, create a select statement of, and then I can then say, okay, this is my class grades, that's my data frame. So I can select that. You can see how I get my final grade. So that's using SQL. That's how to use SQL. That's how you can use SQL DF and how you can actually use SQL against the data frame in R. Run out of time real quick. If you have SQL Server and you want to use R, sometimes you have to install packages. You have to install packages that are not default packages of R. SQL Server is how you would do this on the actual server itself. We've set this vibe.sql variable equal to the path of where your R services is installed on your library is installed on your SQL Server. This is the package I want to install into this library. And you just want to make sure you run this as an administrator using the R console. And if you start playing with this, I mean, we're short on time. I'm trying to just give you all the stuff you need to do. If you start playing with that and have problems, just hit me up. RODBC, here's an example of how to use the RODBC package to connect to SQL Server, create a query, and then return that as a data frame. So in this case, results as the data frame. Another thing is if you install the Microsoft R clients, I showed you a link to that earlier, and you want to actually from your client connect to R services on your SQL Server, you can use these. You can use this R SQL Server data functions to connect to your database and run it inside your database. And then this is just some different stuff. This is just, hey, if I want to generate a logistic test, but ignore that for now. But that's the part of that. So let me go back here real quick. I'm just going to go over this. So where's Microsoft putting R in the SQL Server? I'll just get to this part and then I'll open up the questions. So our Azure Machine Learning has the ability to execute R scripts. So this is a whole other different thing to get Azure Machine Learning, but you can drop in this execute R script and then you can edit it, and basically what you happen is you have a port in, you have like 3 ports in. So in this case, data set 1 will be coming in through this port 1, and then I can do stuff to it. And then I output on these 2 output ports here. So I have 3 input ports and 2 output ports. In this case, mammal map output port equal to this data set. So I'm reading, and the thing to note is everything's written as a data frame into here. So you use it in the ML, Azure Machine Learning. R, like I said, is in the SQL Server. It used to be called, in SQL Server 2016, it was called Microsoft R Services. Now it's called Microsoft Analytics Services because 2017 supports Python as well. Here's some kind of information on what they're doing. Here's some links on 2016 how to set up the R services, how to upgrade, some differences, but I'm not going to go too much in that because what I want to show you is just a little quick demo of how to run it. So the main part is this SP execute external script. This is what is used to actually execute the R code inside the R services in your database. And let me do that demo real quick. So what's cool about that R services is, and the reason why you would want to do this, if your data is in SQL Server and you want to run R against that data, I highly recommend you use the R services. You'll do some research, scale out, right, determine whether you want to run the R services on the actual SQL Server box or you want to run it external from the SQL Server, you can do that as well. But typically I run R services on the same box here. And then what happens is one of the things you have to do is once you install the R services, you have to run this SP configure command to enable external scripts, run reconfigure, restart SQL Server. And then this is a demo script I have out there. It's based on Microsoft. If you want to run this demo script, just create a database called Intro to R, and then you can run through this. I'll just walk through what it's doing. I won't actually run it. But what it's doing is creating a proc called get iris dataset. So the iris dataset is a built-in dataset in SQL Server, in R. And so what I'm doing is reading this dataset in R. So I built this procedure that says get this dataset. And so this is using the SP external script, using the R language. So if you're using Python in 2017, you'd have Python there. It's taking and creating a variable called iris data, reading that variable set to the iris built-in data set. There's no input data, so that's null. And then the output data is iris data set. And then what I'm saying right here is saying, hey, this is a result set. So when I execute this proc, I'm going to get a result set back with these columns. And these columns I know are what's in this built-in iris data set in SQL Server. So I get that back. So then I can create a table from that. So the table exists, I drop it, create the table as this, and then I insert into this table this execute, this proc. And so then it goes to R, grabs the iris data set, and returns it and loads it in this table. And then what I do is I'm going to generate a model. So I'm going to use this package called E10071. That's that code I showed you earlier, how to install this package in the SQL Server. And then by using this package, I can take this data I loaded right here. In this case, don't worry about the statistics. We're just building a nice base classification. So what this iris data set is what type of iris it is based upon petal width and sepal width and sepal length and petal length. It figures out what class, what type of iris it is. And so we're classifying that and we're training the model. And then what we do is we output that model as a var binary map, so as a serialized object. That's what this as raw is right here. And then we load that into a model table as a var binary. And the next thing we do is then say, hey, let's take this model we built and let's try to predict against it. So I have a prediction right here. I use this predict function. Here is where I'm taking and unserializing this iris model. So that's where I have this input data down here, which is, here's my input data 1 name, and then here's my params, iris model var binary max. And this is where I'm passing in to the model where I saved. And then it outputs out my prediction. So you can play with that. I'm kind of running out of time, but all to kind of overview exactly what this is doing is it's pulling a sample data set that's in R, loading into a SQL Server table, running a classification model against it inside of R, and storing what that classification model is into a table as a var binary max. And then saying, okay, let's take that same data and use that model we trained and stored, read that model that we trained in, and then train the data against it, and then output that data to a table and show you the results. So unfortunately, my SQL Server is broken for running R, and so I can't show you this, but it's all self-contained. So literally all you do is create a database called Intro to R, and then you can open the script. It's on the OneDrive, hit F5 and run it. So that's that. And then the final thing I'll show you is Power BI. So Power BI has the ability to run R code in it. And so all you have to do is make sure you enable script visuals, make sure you go to R scripting and you have it's detected your R home. It's okay. And then you're able to do that in R. So let me just show you that real quick. So basically, when you have the R enabled, you can use this little R function. So I have that empty cars data set I showed you earlier. I've loaded that in through Power BI, and then all I do is I click this R right here. When I clicked it, I selected the columns I wanted for this R, and then it gave me this little editor down here. And what it did is it built a data frame from the columns I selected, and then from that data frame I can do what I want. In this case, I just created a box plot of miles per gallon versus cylinder. And so it's creating an R graphic. So what's cool about that is you can do all kinds of things. Like you can use it to build models inside of Power BI and R and output results from the model. If there's some visualizations that R can do that Power BI can't do and you want to show those type of visualizations, you can do that using R inside of Power BI. And then just to finish up, and then if you have any questions, so resources. This UCI IDE site is really good. Has a lot of samples of R for statistics. R bloggers, they have a daily email. Sign up for that. Quick R, it's a decent little book to give you a review of R. Hadley Wickham, he is the king of R. I mean, go to his site. He has really great books. There's one called R for Data Science, and you can actually read the whole book online, but you can also buy it as a hard copy. Data Camp, Coursera, Microsoft Academy, and a lot of good classes of R. And then the last thing I have, and I mean, if you guys want to stay online, we can do it, is this linear regression demo that's out there. And all I do is I'll walk you through real quick, is I use Accelerate in movies. So first week in box office releases, how much money they made. I read that in. As a data set, I set some of the variables as factors, and then I create a sample and training validation data set right here. Show you some summary information about the data set. I then go in and show you how I need to do what's called a log transformation on the first week in box revenue because it's skewed. Build the model against it, show you the output of that model, save the model that I build right here. And then I can then load in my validation data set, and my model, and then predict against my validation data set and get the results. So what that looks like real quick, because I know we ran out of time, run it. So I set my variables, use the read Excel package, read in my data set. So this is what the data looks like. So week in box office, there's the movie title, how much revenue they made, number of theaters, data release. This is like views, I think, of like the web page or something for the article. Then some other variables I created. So I'm going to create factors. So I'm taking SQL as like yes or no. So I want to create those as factors. The month of release, whether it's January for a month, I create those as factors. Set the row names equal to 1.5. And then I set a seed so that it's always split the same way. Use this thing to create a probability of 70% for training, 30% for test, and for validation. Split those data sets up, just some summary information of the data itself, plotting. So this is the plot of first revenue for first week in box office, and you can see it's skewed. So in statistics, what we do, and let's skip ahead, is we'll usually do what's called log transformation. And so I have a variable in there called log first week in box office, and now you can see the log transformation gives me this normal distribution. So when you're building linear models, you generate your model to be your variable to be normal. So the log transformation, it helps us. Here's a linear model I built. Here's the summary. This is a statistics class, but ones with stars are significant. That's bad. So use this called the step function, what's called stepwise regression. And then I end up with, hey, I can predict first week in box office by just using number of theaters and the views. And then create a data frame, train them out, and check validation. So I've saved out my model, I loaded the model back in, I predict against the validation, and then view my prediction results. So you can kind of walk through that and play with that. So, and that is it. Thanks for attending. If you have any questions, let me know.
Thank you. I don't see any questions. Here is applause for you. You hear?
I apologize about the sound. I don't know if it's just the how far apart we are or whatnot. But,
Sorry, I didn't hear the last sentence.
Somebody said that the sound was bad, so I apologize.
Sound was okay most of the time. Sometimes when you moved from slide to slide, I think you get far from the from a microphone, and then it went bad, and then it came back. But most of the time it was fine. Thank you very much. It was awesome sessions. Was recorded, and I will be, if you don't mind, we'll put it on our YouTube channel.
That'll be fine.
Thank you everyone for joining, and have a good day.
You the same.
Bye bye.